This video is about lambdas and closures in functional programming. Lambdas and closures have to do with the idea of first-class functions. For any programming language, the idea of a first-class citizen is an element of the language that's integrated tightly into the language, and it supports a lot of the operations that you would expect most types to be able to support. What does that mean? Well, it's hard to explain actually, because we take this for granted when we write code. We assume that if we declare a variable, and it's an int, it's a string, it's an array list, we can do a bunch of things with that variable. We can store it, we can modify it, we can print it, we can pass it as a parameter to a function, we can return it, we can make a sequence, a collection of those things, we can make a list of ints, we can make a list of lists. We just assume that we can do all these things. We take it for granted because those types are first-class citizens of the language. You can treat them as data. You can do anything you want with them. Well, we can do this with primitive types of data and object data in Java, but one other type of data that's common in functional programming is to treat a function itself or a method as a first-class citizen. So in other words, you could do things like create a variable that stores a function and then use the variable to call the function later. You could pass a function as a parameter to another function, and then that other function could call the first function through that parameter. You could return a function as a return value from another function. You could make a list of functions and loop over the lists, and it would call all of the functions. I mean, all kinds of things like this. If you thought of functions as first-class citizens of a programming language, then you would be able to do those things with functions. Java doesn't totally support that concept of functions as first-class citizens, but the changes that were made in Java 8 to partially support functional programming concepts do bring Java closer to this idea. A key construct added to Java 8 is called a lambda expression, sometimes just called a lambda for short. It has to do with the idea of lambda calculus, which is a system for talking about programming languages. A lambda expression is one that describes a function simply in terms of what parameters it takes and what function or what return value the function produces. And maybe that description sounds a little vague, but usually part of lambdas is that they are anonymous. You do not give them names. And you simply write the parameters and then some sort of arrow operator and then a return result value. Look at the example on the slide here. It's almost unclear where the code is. This is the code for a lambda expression. And the meaning of this is you're saying, I'm going to write a function. This is a declaration of a function, a method, basically. And what you're saying is, if you give me an x, my behavior is to return x times x. I will convert x into the square of itself. That syntax is a very, very short version of the following syntax, declaring a method named, I don't know, squared or something that takes an int parameter x and returns x times x. All of that is basically shortened into this lambda expression. Now that's cool. It makes functions shorter and easier to declare, but it's not just used for that purpose of shortening the syntax. It's also used in the sense that we can pass lambdas around and then invoke them elsewhere in the code. That's a very powerful idea. I think it's hard to understand that idea until we explore it with an example. So let's look at a program right now. Imagine we're going to write a math tutor program. We can ask the user math problems, like let's start with addition problems, maybe also multiplication or subtraction problems. So we prompt the user, what's 9 plus 6? And the user has to type in 15. If they get it right, we'll tell them that they got it right. Sometimes we want to give them multiplication problems. What's 3 times 7? The user gets it wrong, types 18. So we print, oh, you got it wrong, the answer was 21. Okay, that's not such a hard problem to write. We could have written a problem like that after chapter 4 or 5, right? Once we know about while loops and if statements and random numbers, these kinds of things, we can write a program like this. Okay, but how could we write it more easily and more concisely using functional programming and lambdas? Well, let's look at the code. This is the math tutor problem. And right now what I have is a simple main method that constructs a scanner, and now we have a method called quiz that uses that console scanner. The quiz method is fairly straightforward. I'm not going to belabor the code so much. The quiz method makes a random number generator, produces 2 random numbers from 1 to 12. It asks you what is the sum of those numbers. It calculates what the correct answer would be. It asks you for your answer, and if you got it right, it tells you that, and if you got it wrong, it scolds you. That's it. Okay, simple program. Now, let's talk about what if we wanted to do multiplication instead of addition. What parts of the code do we need to change? If you want, you can pause the video for a moment and look at this code and think about it. It turns out that there are only two places the code needs to be modified to turn it into a multiplication quiz. You change this print message to say times instead of plus, x times y equals, then the correct answer is x times y. Do you see? Those are the two places that we would need to change the code to be a multiplication quiz problem. Okay, but what if I want the same piece of code to do either one? I want to be able to ask the user either addition problems or multiplication problems. How do I parameterize that? Well, you can probably think of some ways to do it using material from previous in the textbook, like passing a Boolean flag, true for plus and false for times, this kind of thing. But it doesn't generalize very well. What if you want to support subtraction, division, everything, all kinds of operators? It doesn't work very well. So you could imagine passing more parameters, maybe passing some representation of what operator to use. Let's think about that for a second. Up here I say quiz console. What if I say quiz console plus, and that means it's an addition problem? Okay, well, how would we incorporate that into our code? Well, we could, have a new parameter here, and we could say string op. What operator are we going to do? Okay, remember the two places in the code? We're supposed to change this message and this thing here. Okay, well, we could do that. We could say instead of plus here, we could say plus op plus that, right? So it'll say x times y or x plus y. Maybe I'll write another one here that uses multiplication, another call. Okay. So now what about the other place in the code? Wait, sorry, I think I'm supposed to remove that one there. Okay, x op y. So it'll print x plus y or x times y. Oh no, wait. There, I think that's better. Okay, anyway, the other place we were supposed to modify the code was this. If it's a multiplication problem, it should be x times y. If it's an addition problem, it should be x plus y. So we wish we could just put whatever this operator is in here. Maybe we'd say x op y. Sadly, Java doesn't support that. That syntax doesn't work. But that's basically what we want to do. So maybe what we could do is we could pass another parameter, which is a function that tells us how to calculate the right answer. And that's where these lambda expressions come in. Let's look at the syntax again. The syntax is parameter arrow return. Here's how you use this. You come back here and you say the way to calculate the right answer is using a function that takes an x and a y and it calculates x plus y. This entire thing here is a lambda expression. We're passing it as a parameter. Again, this goes back to that idea of functions as first-class citizens. We can pass a function as a parameter to another function. Then here for this multiplication one, this one takes a different lambda, returns x times y. So the syntax is a little cluttered here, but basically there are three parameters to these calls: a scanner, a string, and a function. So now if we're passing a function as a third parameter, we have to represent that here in the heading of the quiz method. How do you pass an int lambda as a function? Well, we talk about it a little bit in the chapter, but there's a data type representing this sort of lambda that takes two ints and produces a single int. It's called an int binary operator, and I'm going to name it func because we're passing a function. If you want to pass functions as parameters like this, you have to go up here to the top of your program and you have to import a package named java.util.function.star. Might be worth looking through the Java documentation for this package to see some of the other types of lambdas and utilities that are available. This binary operator, this function, this variable stores this lambda or this lambda. It represents those functions that we want to call. So now remember how I wanted to say x op y? Instead I'll say func x comma y. That's basically what we want to do. Unfortunately, that syntax doesn't quite work. That's not how you say it in Java, but do you understand? That's the idea. You give me a function, and then here I will call it to figure out what the right answer is. And if the function is an adding function, it'll do x plus y. If the function is a multiplying function, it'll set the answer to x times y. That's basically the idea. The one little piece of syntax that we have to add here is we can't just say func xy. We have to say, hey func, apply yourself as an int. That's just the way it's written in the Java 8 features. If you have one of these functions as a parameter, you have to tell it to apply itself to these two parameters. And again, x and y now are these two here. So if I compile this and run it, it'll say 9 plus 2. That's this first one right here. And if I write 11, it works. Now the second one, it's doing this one. And look, it says 7 times 5. Now the reason it says times is because this star is called op here, and it's printing that op right there. So to get the right answer, if I say 22, it will say incorrect. The answer was 35. So you know that in order to calculate the 35, it applied that function that we passed as a parameter. It applied it to the ints x and y, which are the randomly chosen values of 7 and 5. So this is a pretty powerful idea, because this program now is really easy to extend to support other operators. For example, if I want to support subtraction, all I got to do is just pass in a minus and then do another function that does x minus y. So there you go. Let's try it. Let's run the program again. Now that I've got minuses, let's try 16. I got it right. 11 times 3, that's 33. 12 times 9, I think that's 4, right? Oops, the answer was 3. So now just with one additional line of code, we support multiplication, because this piece of code here has been generalized to support these different binary operators. That's a powerful idea made possible by the new Lambda features of Java 8.